Okay, so today I'm going to go over quickly with you guys graphing systems of inequalities. Um, so let's just start with example number one. The first thing you want to have them is in y form. So the very first equation is already in y form. So the equation one, we're going to use red. It's in y form. And then the second equation is not in y form. So we're going to subtract x from both sides. And that's going to give me 3y is greater than or equal to negative x plus 3. Because these are not like terms, you can't combine them. And then we have to divide everything by 3. You could, if you want to save a little bit of time, right? To save a little bit of time, you can just say, we're going to move the x over, so that's going to change signs. So whenever you move something over to the other side, it changes sign. So that makes the positive x become a negative x. And then we got to divide everybody by 3. And that gives me y is greater than or equal to, and then remember that coefficient's -1, so that'd be -1/3 x, and then 3 divided by 3 is 1. So there's your second equation, and we'll put that one in blue. So those are the two equations we have to graph. So remember, when you graph, you have to do the y-intercept. So the y-intercept is the b part, right? When you have y equals mx plus b, and the m is the slope, and the b is the y-intercept. So the coefficient of x is the slope. So here the y-intercept is 0, -2. So that's your y-intercept. That's where it crosses the y-axis, is down here at -2. Then we're going to use the slope to go up 1 over 1, up 1 over 1. And it has to be in a positive direction, right? So this is going to be the first line. Now the question is, should it be a solid line or a dotted line? So we go up here to look at this information to decide whether it should be dotted or solid. We go up to that information. So what is it? Would it be dotted or solid? Well, it has the equal to symbol underneath it. So since it has an equal to symbol underneath it, it should be solid. So we're going to make that line a solid line. And if it was dotted, you'd go something like this. You'd make a dash line. But it's solid, so we want to run through it all the way. Make sure it's very clear on your paper whether it's solid or dotted. Sometimes I'll even write dotted out there if you can't tell. And then we need a shade. So then where do we shade? We have to shade, its y is less than. So if it's less than, we're going to shade either above the line or below the line. So since it's less than, we're going to shade below the line, right? Because it says less thans are shading below the line. So we're going to shade everything below the line. So what that means is anything in the shaded region actually will work for the red equation. So anything in red is actually going to make those xy values would make that top equation true. Then we're going to graph the blue one. So remember, we're graphing this one now. So we have to start at the y-intercept, which is +1. And I want to get rid of this stuff. And it's a negative slope. So it has to be going in the negative direction. And it's a 1/3 slope. So I have to go up 1 and over 3. Up 1 and over 3. Down 1 and over 3. And down 1 and over 3. And down 1 and over 3. So you really have to graph all the way. And that also happens to be a solid line. And now we have to shade. So it says y is greater than, and if it's greater than or equal to, we shade above the line. So we should be shading above that line. So anything in blue is actually going to work for the blue equation. But we are solving a systems, and a systems is when you have more than one equation. So we have two inequalities, so that's a systems, and we're looking for what xy ordered pairs will work for both. So if I look at this point, if anything in this region isn't going to work for any of the equations, a point here in here is only going to work for the blue equation. Points over here only work for the red equation, but these are the points that work for both. So we want to represent what are the region that works for both. So we want to have only where it overlaps in both colors. So we want to erase this and have, and maybe we can even darken that in with maybe I'll use green. So this is where they work for both. And so that's, on these ones, your answer is a shaded region. So the shaded region is where they work for both. So if you were to pick a point in the shaded region and you were to plug it in for both of these equations, it would make both of them true. So any points in this region will make both of those equations true. So these are the solutions to the systems, right? So that's the solution to the system. Okay, let's look at the second one. The second one, notice we have an absolute value graph. And you're supposed to recognize by now that if you have an absolute value graph, what's that supposed to graph like? Right, it's supposed to be a V, right? And so don't you have to first determine the vertex? So wouldn't you want to, like, what is the vertex of this problem? So it goes back to your skills from before. So isn't the vertex 2, 3, right? The vertex is 2, 3. And then, so we're going to plot 2, 3. And then is the V opening up or down? It's going to be opening down because it has a reflection. And then it has a slope. The branches have a slope of 1/2. So it's up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2. And that's one of the branches. And down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2. You want to kind of go as far as you can. And then should this be a dotted V, or should it be a dotted V, or should it be a solid V? So since there's no equal to symbol underneath here, it should be a dashed V or a dotted V. So make sure your dashed lines or your dotted lines are very noticeable, right? And then the second equation I'll do in red. So the second equation I'll do in red, that is when you have y equals a number, that's going to be a horizontal line. So this is basically, we're graphing y equals 1. So we're going to graph y equals 1, which is going to be this line here, and it should be a solid line, right? Because of the equal to symbol, it should be a solid line. So here's the y equals 1 line, and we want to shade anything above that line. So we're going to shade everything above this line. So this is like the arrow technique. So everything above that line is going to get shaded, and then the V, everything below the V is going to get shaded. So we're going to shade everything below the V. So do you see where those overlap? Right? So you see that where the colors are going to overlap. So the colors are going to overlap in here. So we're going to shade where they overlap. So that's a technique, is using what we call the arrow technique to kind of help you see where they're going to overlap, because we're looking at where the shadings overlap. So that should be your final answer when you submit it. Okay, so let's try another example. Right? So let's try one more example. Just trying to make this video. Okay, so this time we have 3. So I'm going to do the top one in red. So that is like a y equals number. So this is going to be a horizontal line. If you go back and look at the notes, so that's going to be at 4, and it's going to be solid. So 1, 2, 3, 4. So that's going to be the solid line. So I'm going to write y is less than or equal to 4 line. I'll do this one in green. That one's going to be a vertical line at 3, and it's going to be a dotted vertical line. Like, do you know why it's dotted? Because it doesn't have that equal to symbol. And make sure you go way above. And then this one is going to be a y equals mx plus b line. And we have to first get it into slope-intercept form. So we're going to move the negative 8x over, so that gives me negative 4y is less than positive 8x minus 4, because I had to move it over, so I had to change the sign. Then I have to divide everybody by a negative 4. And what do you remember if you ever multiply or divide by a negative when you're working with inequalities? Don't you have to remember to reverse that inequality? And then 8 divided by negative 4 is negative 2x. And negative 4 divided by negative 4 is a positive 1. So now we have to graph this guy. So we're going to start at the y-intercept. So we're going to start at positive 1. And then we're going to use the slope, which is up 2 over 1, up 2 over 1. And it has to be in a negative direction. So from there, I'm going to go up 2 over 1, up 2 over 1, up 2 over 1, down 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 2 over 1. And is that solid or dotted? It is a dotted line. So it's going to be a dotted line. And then we have to figure out, so this is the y is greater than negative 2x plus 1 line. And I like to write my equations next to each one, so that way when I'm looking at them, I can look at this instead of my eyes having to go way over there. So I think that's useful. So I want everything that is less than 3. So that means I'm going to shade everything to the left of the green line, right? Because I want all numbers that are less than. And then for the red line, I want all numbers that are less than 4 or equal to 4. So aren't numbers less than 4 below the line? So this is like the arrow technique. And then for the blue line, I want everything that is above the line. And everything that is above the dotted line, right, would be up here above this line. So I'm going to shade everything above. And do you see where they all overlap? So where they all overlap is in this little triangle region. And you want to make sure you go all the way out to the boundaries. We call those the boundaries. So we want to make sure it's clear where the boundaries are. And so that's what your final answer should look like. And then we should, clean it up and do a little bit of erasing and erase those arrows, right? Erase the arrows so we have just that picture. So I hope you find this quick video on graphing inequalities useful. Bye.